So, very warm welcome, everybody. My name is Paul Kennedy. I'm from Zindi. Today we are the Intro to the Finance Challenge webinar. This is a webinar that is designed to give participants in the AI4EAC Finance Challenge information about the challenge, some background information on the uh, the host who is providing us with the challenge and the data, information about the data itself, information about the challenge design, the how you'll participate. It will include some information about evaluation metrics, and there'll be a chance for you to ask any questions that you may have. The session is being recorded, and we will make the recording available for those of you who aren't able to join us for the full webinar and for future reference when you're working on the challenge. So, in terms of an agenda, we are going to start with an introduction from myself. Then I'm going to hand over to Ali Juma from Credible, who is our data partner for the challenge. Ali will tell us about Credible and about the challenge data that we are working on. Then we will hear from Joel Lontsi, who is a Zindi data scientist. He will take us through a bit more detail about the design of the challenge, how you can prepare for the challenge, and a little bit more about the specifics like the evaluation methods we will use, and so on and so forth. There will be some time for questions if you have any, and then we should wrap up, yes, in a little under an hour. Before I hand over to Ali, I wanted to tell you a little bit more about the AF/EAC Innovation Challenge program. You may know this information already, but in case you don't, there are four different streams. The streams are health, finance, education, and agriculture. The health and finance stream are beginner friendly and beginner focused. So if you're a beginner to data science and machine learning, beginner to AI, these are the challenges that you should be thinking about working on, and you're in the right place because this is the introduction to the finance challenge, which is part of the finance stream. In terms of the challenge weekend that we have coming up, the hackathon will take place on the 28th and 29th of March. That is this Saturday and Sunday. We'll see students from all over the EAC region, 8 countries, more than 100 universities represented, and more than 3,000 students. In fact, that number's out of date. We've now had more than 3,500 students registering for this event. You will have been able to, through the Innovation Challenge program, you'll have been able to grade your skills in AI, machine learning, and data science. Now, this hackathon is a challenge that will allow you to put those skills to test. It's a hybrid event. It is taking place online, and you can participate entirely online on Zindi, but it is also coming to satellite universities around the EAC. So if you are based in one of the largest cities in the EAC, keep an eye out for more information about a university near you that will be hosting students, and you may be able to participate in person at those universities. There'll be more information about the university hubs available both on Zindi's website as well as in mailers that we will be sending to you if you've registered for the challenges. Overall, we have more than 30,000 US dollars in prizes across these challenges, as well as other prizes like swag, as well as some internships for working at various startups in the AI space. So a lot to play for. And if you don't win prizes, you will of course still be learning and growing in your AI career. With that said, I'd like to now hand over to Ali. Ali, you are free to share your screen, and Ali will take us through a bit more info about himself, as well as about Credible and about the challenge that we'll be working on. Over to you.
Thanks, Paul. Let me just share my screen, make sure everyone can see it, and we can kick off. Okay, hopefully that's visible for everybody.
Yep, we can see your screen.
Great. So yeah, quickly as Paul mentioned, I'm Ali Juma, head of Credible or head of data at Credible Group. So I kind of oversee data science, data engineering, and data analytics as a department here. So I'm going to quickly give you a quick rundown of Credible and what we do and how we work, as well as how we use data and kind of the approach for credit scoring that we are focused on, and then get into kind of the data set itself, um, walk through it high level, give you some insights on maybe things that you should know, and then I have kind of a breakdown of just the full schema of the columns and descriptions. For that piece, I'm not going to go in detail here, but this will be available for everyone to reference after this session. So just who is Credible Group? So we are a digital banking platform that partners with channels to deploy credit and savings products at scale. So our whole model is based on partnership. Um, and it's based on an embedded model. So what this actually looks like is we have Credible essentially acting as an enabler. And we typically have two partners that we are operating with. One is on the balance sheet side. So this would be a capital provider, a bank, a fund who has balance sheet that they want to deploy in a lending or savings capacity. On the other side, you have essentially channels. So this is where the customers actually are. So think of your Safaricom, your Airtel. From an M&O perspective, it could be within banks, it could be within fintechs. But this is who we actually embed our credit and savings products into. And with that, we are deploying loans, BNPL, overdraft, savings, any kind of range of credit and savings products that are enabled by our platform. And all of that ends up going to the consumer. And so I think two critical things of just how we work is one, this B2B to C model. So we're very much focused on enabling customers for our partner channels, not our own customers. And secondly, is that we're embedding within their ecosystems. And the reason this works really well is these channels often have a massive user base who would be interested in these financial services, but often those channels don't understand or have the capacity to offer the financial services, the scoring, the reconciliation, the loan management, all of those components that are necessary for a product like this. So we're able to bring that to the table. On the flip side, the balance sheet providers may have capital they want to deploy. They would want to accelerate their digital footprint, but they don't have, again, the capability and more importantly, the customer base. And so we kind of act as this middle layer that enables this end to end. Now, when we look at the data and the data practice itself, the main use case and value add that we're focused on and what we're trying to drive home is essentially this thin file decisioning. A lot of consumers are kind of locked out of the traditional financial services ecosystem because they don't have a real credit history. They might not have a bank account. They aren't able to take loans. They don't really have a proper savings mechanism. These customers, there's not very much data on. And so that's what you call thin file. What we do know, though, is in most of these markets, they are active, especially in the mobile money ecosystem. So M-Pesas, the Airtel monies, these are ubiquitous across a lot of these emerging markets and within these countries that we operate in. And so the entire thinking of what we do is how do we leverage these alternative data sources to properly risk score our customers, something that traditional bureaus aren't able to do. How do we use other data sources that may be available, bureau data, utility data, behavioral signals, anything else that might have predictive power? And essentially, how do we turn those into models that predict default for credit, predict churn, predict lifetime value. Essentially, what can we create that manifests a credit decision where we can bring in this unbanked or underbanked customer and actually enable them to participate in the financial ecosystem with microloans, with savings accounts, and take them on a journey, ideally, into financial inclusion. So, why this matters? Alternative data is kind of one of the only paths for formal credit for a massive chunk of emerging market consumers. And predicting financial distress is something that helps us lend responsibly. It's critical for us to understand we don't want to lend to someone and know that, oh, they're going to run away or we're not going to get a repayment. They're going to default, which further hurt their credit history and their ability to participate in this ecosystem. So it's very critical not only to offer this service that enables credit to a segment of the population that previously maybe didn't have access to it, but also to do so in a responsible way. And that's where the scoring becomes pivotal to this practice. So now if we change gears a bit, I'm going to start to talk about the data set that we've shared for this particular hackathon. And this is an anonymized synthetic mobile money data set on 10,000 customers. There's 70,000 records, 226 columns, 7 mobile money transaction categories, and it has rolling 6-month snapshot of what their behavior looks like over time. There's the customer profile data and then the category signals. So essentially, this is very much in line with something that we at Credable would look at and use to understand and score a customer and come back and decide who is eligible for a limit, for to take credit, how much should they be able to take. All of these decisions come off of a data set that's very similar to what you guys will be working with for this exercise. Now, a few things I want to highlight along the way. One is the data is not perfect by design. There's historical data there. There's different attributes that are all could be used and may have predictive power. But I think a critical component of what it means to be a data science, what it means to do this scoring and decisioning process is to understand kind of what things look like in the real world. And the real world financial data is never pristine or clean or ready to go. So it's important that you take a look at what the data is saying, where you see gaps, where you have concerns, and make decisions on how you will use that data and what assumptions you will take to build your models for the exercise. Just a few other things to know. I won't go too in detail, but each category essentially carries 5 signals. So, for example, you have pay bills. So payments that are made by a consumer, and that has pay bill information by volume, by value, by highest transaction, by number of recipients, and then by the latest activity date. So this gives you insight both on how much and how often a behavior is happening. Nulls are meaningful. They should not be discounted in this situation. It just means that there was an activity, but not that there's missing data. So a null is something that you need to take into account as you're doing this. The rolling window shifts that you'll see in the data set, it's essentially showing for month 1 of that snapshot, here's what they did. Month 2 means historically 2 months back, and 3 months back, so on and so forth. And again, all of this will be shared, and I have it in more detail in the following slides. So don't worry about missing anything here, but I just wanted to quickly touch on some of the particulars around the data. Daily average balance isn't part of those 7 categories, but it's something that we found is very useful to understand for a consumer in terms of their general inflow outflow behavior. And then you have a number of profile fields: age, gender, region, smartphone ownership. These can or cannot have predictive power, but they're interesting things to take into account as you're building a model overall. This is essentially the data dictionary that I've kind of outlined here, and this gives you a bit more detail on every single column that's in the data set and a quick description on what it is. Some of them are very straightforward, especially these more demographic items. There's also, then you start getting into some of the metrics. So MX is essentially when you start seeing M1 daily average balance, M2 daily average balance. And essentially that's saying in month one from this date, this was their balance. And so that gives you kind of a look back period for you to reference as you build. And I think it hints at the importance and value of feature engineering on the data set overall, which I hope you guys will get creative and think about different ways to manipulate and create features that make sense for this exercise. Going in more detail, so per category transaction types, as I mentioned, each one breaks down volume, total value, highest amount, recipient, last date, and then the actual transaction types that we have available. So there's pay bill, which is making payments, merchant pay, which is specifically merchant transactions, transfer from bank, so money coming in from the bank, mobile money send, so sending money out to another user, received is getting money received from another user, deposit is cash deposit into your mobile money account versus withdrawal is cash withdrawn from your account. And so you see each of these have an outflow or inflow designation, which is another way to kind of look at the behavior and create some clustering and understanding of what's happening around this. And all of that kind of leads into what this challenge will be. And I think Joel is going to take you into a bit more detail on the mechanics and the design and what the expectation is. But I think that covered at least the data set and kind of a little bit about what Credable does. So with that, I'm going to pause. If there's any questions or things that you'd like to clarify, I think this will be a good opportunity just to ask away.
Thanks so much, Ali. Any questions? Please do feel free to type them into the chat or just to mute and ask them straight out. While we wait, Ali, do you do much modeling yourself? Are you building models at Credible?
I've I did one or two just to have the experience, but no, not myself. It's not my day to day. I'm pulled into a lot of other things. What happened if credible above 6 months?
You don't understand that question. What happens if Credible above 6 months? I'm not sure. Lewis, if you can try and add more context to the question, that would help us to be able to answer it. I don't totally understand the question. Yeah, I was wondering, I was asking about modeling because maybe you would know like the types of models that get favored at Credible or
Mm.
things that you
Yeah,
know work well in the mobile money space.
I mean, I think there's different pieces. So as far as modeling, I think often we end up leaning towards a regression model initially, and that's more because of what the partner needs, especially the bank, who has kind of overall, you know, approval of what we're doing. And the reason regression models is kind of the starting point is for explainability. These
Mhm.
advanced models are very powerful and can do a lot, but you don't really understand what they're outputting. And so for the bank, that's critical from an audit and regulatory perspective. So you often end up starting with regression. You can use these more advanced models for specific use cases and outcomes, but for a pure decisioning model, you're often starting with that. That kind of sets your boundaries and guardrails, and then you can can build on top of it.
Yeah, it's interesting. It's certainly a perspective your average data scientists wouldn't take, worrying about explainability of their models. They just want to get the performance they can.
100%. And I mean, that's one of the things of real world, use cases versus just playing
Mm,
with these things is yes, you can predict something very well with some of these advanced models, but you have no idea why or what's happening under the scenes. And that can be a roadblock
yeah.
for real world use cases.
Okay, cool. Okay, I don't see any other questions, so I think we can leave it there. If there are some specific questions, we'll have some time towards the end. Ali, I know you need to drop off for another engagement, so if there's a question that we can't answer, I'll send an email your way, and hopefully we can get that resolved. Thanks very much for your time.
No, thank you so much. Look forward to you guys taking on this challenge. Like I mentioned, we'll be sharing this deck with the details of what I went over. So you'll have that reference and good luck.
Thanks so much, Ali.
Okay, cool.
Thank you.
Cheers.
Cheers.
So, next up we have Joel from Zindi. Joel, are
Okay.
you ready to go?
Yes, I can share my
Okay,
slide.
please go ahead.
Okay. Hopefully you can all see my slides.
Yes, it's visible.
Okay. Yeah, yes. Okay. Ali took us through the data. He explained the structure of the data. I'm going to discuss the challenge design and what the main task is. So yeah, if you go to Zindi, there's a challenge called liquidity stress early warning. I mean, you have the liquidity stress early warning challenge. That's the challenge that is being offered for the finance track of the AI4EAC program. Okay, and the task is to build a machine learning model to predict which customers are likely to experience financial stress within the next 30 days. So as Ali explained, the data set will consist of mobile data transaction for a period of 6 months. And the idea is to build a machine learning model to build a machine learning model to predict which customers are likely to experience stress. So basically what this means is your target is a probability value between 0 and 1. So the closer to 1 it is, so a probability value between 0 and 1, indicating whether the customer is likely to experience stress or not. Basically, what we mean by stress is you will have to, I mean, based on the transaction data, right? You will have to build a model that can learn the behavior. I mean, the behavior that customer are exhibiting. For example, let take a simple example. If you have a customer that is not looking at their transaction, maybe they are spending more money than they are earning, and they are not repaying their loan. They are default. I mean, well, they are spending more money than they are earning, and the frequency at which they are borrowing money is increasing. Those type of things. Then you can probably guess that they're experiencing some stress because they're having some issue with money, and yeah. So that's basically what it means. I don't know if that makes sense. Is that clear, or do I need to explain further what we mean by a customer experiencing financial stress? Yeah. Okay. So the data set is tabular. So you have a tabular data set with all the different records. And we are going to use two evaluation metrics, log loss and RUAC, AUC. Okay, So what you're actually predicting is the probability. So you're not predicting the binary target 0 or 1. You're predicting the probability. Okay, right. And in terms of submission file, your submission file is going to be a CSV file with 3 columns. There's the ID column, and then you have 2 additional columns, target lock loss and target RAUC. So the value in target lock loss and target ARUC are the same, right? So we are basically just duplicating the same column with different name. I mean, this is we have to use this format because the evaluation metric or the code that does the scoring need the 2 separate columns, and each column is used for a specific metric. So target lock loss. So the target lock loss column is the column that is used to scored against the reference file to actually get your lock loss score. Now the reference file which you're not given actually has the target value, i.e. 0 or 1, depending on whether a particular customer is experiencing financial stress or not. Okay. So that format need to be followed that way. Okay. And I think Ali already went through this. Basically, you have a data set consisting of mobile money transaction over a 6-month period. And you will have different columns. Some of the column you have different columns, and they have different suffixes, right? From 1 to 6, something like that. So 1 will be month 1, for example, and 6 will be month 6. So you have money inflow and revenue. Inflow is, for example, somebody receiving money, and revenue and cash withdrawal, withdrawing money. And of course, people also use their mobile. People also use mobile. Some of the mobile money transactions that people do include paying their bills and stuff. So those are the different kind of mobile money transaction that you have in the data set. So based on all these, you then want to build a model that predict which customer are likely to experience some financial stress or difficulty within the next 30 days. So the next 30 days, that means 30 days after the observation date, because you have a snapshot of data and, okay, 30 days from that date, are they going to experience stress or not? Okay, in terms of the split, I mean, you have 40,000 rows for training and 30,000 rows for testing. And yeah, as you can see, the data is highly imbalanced, right? Because you only have 10,000, about 10,500 positive cases. So that's 1 experience liquidity stress, and 0, they don't. Yeah, so that's what the class distribution is. So that's something you have to deal with, and yeah. Okay. Now, in terms of I mentioned that we are using two metrics. So we are going to use multi-metric evaluation. So the evaluation metric consists of 2 different metrics. So we are scoring against 2 different metrics. And one is lock loss. Okay, so obviously with lock loss, you want to measure how well the probability actually match the actual outcomes, right? For example, if somebody is actually experiencing the financial stress, then the probability should be closer to 1. So it should be a number closer to 1, right? Whereas if he's not, then you want the probability to be closer to 0. And this is okay, and basically, so you report. So what you're going to report are the probability, and this is basically how log loss work. So you take it's just a sum of the, I mean, the probability that you predict times the log of the actual class, where y is 0 or 1, representing the true class. So if pred is the probability that is reported, then 1 minus pred is the probability of the negative class. Again, because the probability have to sum to 1. Right. Does that make sense? Any further? Okay.
If
Right.
people have questions, they're welcome to ask in the chat.
Right. Okay. Okay. In addition to log, so okay. In addition to log loss, we are also measuring. We are also using AUC. Now, with AUC, you want to measure how well the model is ranking customers that actually experience stress from those that don't. So, I mean, the plot on the left shows what the ROAUC curve looks like, where on the axis you have the false positive rate and the true positive rate. Well, maybe, okay, yeah. So obviously the false positive rate, because when you're making your prediction, you can compute what we call the, I mean, you can have true positive, you can have false positive, you can have true negative, and you can have false negative, right? A true positive is when you predict. A true positive is when you predict 1 and the actual class is 1. So, for example, in this case, a true positive will be you predicting that a customer is experiencing financial stress, and the customer is actually experiencing financial stress. So those are true positive. Whereas a false negative will be you predicting 0, i.e., a customer is not experiencing financial stress, but then the customer is actually experiencing financial stress. So the actual value should be 1, but then you're predicting 0. So that's a false negative, because you're predicting false when it's not actually false. Right. And of course, you can then compute the rate of this with respect to all the prediction, and we can generate this plot. Okay, so the metric here, what we are computing, so the score is a value between 0 and 1, and it's actually the area under this curve here. And of course, you can see that the closer you are to 1, the better, right? Because, values that are closer to 1 are on the far right of the plot, somewhere here. But then again, okay, yeah, so the score is not just, it's just, yeah, the whole area, just that area under there. And the idea with this is basically you're trying to see how well the model is doing for different threshold. So we are not setting a threshold, but then for different, probability threshold, you want to see how well it is ranking those prediction. So these two scores are going to be combined to generate the final score. Okay, and Right. So this is what we have. 60%, 60%. So your final score is going to be your log loss score, 60% of your log loss score plus 40% of your AUC score. That will give you your final score. Any question? Okay. Okay, right. In terms of prepping for the challenge, there is a
Sorry,
similar
Joel.
challenge. Right. Yeah.
There is a question in the chat. I don't know if you want to answer it now before we go on to talking about practice challenges.
Oh, okay, cool. I don't understand how we can get negative answer in probability prediction. As we all know, probability is always between 0 and 1. Yeah, that's correct. You're right, right? A probability is always between 0 and 1. So you won't be getting a negative answer in probability prediction. But your log loss score can be negative. That's different. Recall that recall that the log function, I mean, if you take a number less, if a number between, I mean, for a number between 0 and 1, the log is negative, right? And you can put a minus sign in front just to turn that into a positive value. I don't know if that makes sense. Yeah, so your log function will, I mean, log of 1, if you're looking at log, natural log, well, not natural log, let take log, natural log of 1 is 0. And for any number less than 0, less than 1, the log value is going to be negative. But then if you actually multiply that by minus sign, so this value is actually going to be positive. I hope that makes sense. Right, so the probability is positive. You're going to predict a value between 0 and 1. That's correct. It's not going to be negative. Okay, in terms of prepping for the challenge, we also have a practice challenge. For the finance track, the practice challenge is about predicting loan default. So again, in this case, you have a data set consisting of different banking transactions showing what customers are doing, lending money, repaying their loans, and that kind of data. And you want to predict the probability of loan default, i.e., you want to predict when the customer doesn't repay their loan. And again, I think that data set is also in balance. And that's just the nature of the business, right? Because I mean, most often with financial data set, you'll notice that there's a huge imbalance because what you're looking for is actually, I mean, yeah, I mean, most often in the majority of cases, people actually repay their loan. But then again, even if you only have if you have 10% not repaying their loan, that's still, I mean, I guess that's still high. Even though it's in balance, you still want to, if you can still catch that, as the idea is to be able to catch as much as possible. So it's just the nature of the data set. You will hardly find a data set. I mean, if you're dealing with loan default, I mean, most often you'll be working with imbalanced data set. Yeah. So that's something you have to be familiar with. Okay, in this case, we actually only have one evaluation metric. But then again, the process should be the same. So the point of the practice challenge is really for people to get familiar with Zindi, understand how submission works. So make sure you're able to submit And of course, you can submit multiple times. You submit and you get a score on the leaderboard. And of course, also how to deal with this type of data set. I don't know how many people have actually looked at the practice challenge. Has anybody here looked at the practice challenge already? Okay. Right. Okay, cool. Any other question?
Well, thank you, Joel. It doesn't seem like there's other questions, but maybe it seems like a few
Okay, cool.
people
Yeah.
have
Okay.
looked at the practice challenge, which is great. Think this has been a good overview and a reminder to everyone that we will make this recording available from tomorrow on Zindi and on our YouTube channel. You can find these recordings in the challenge pages from tomorrow. Um, and I think we can leave a few more seconds in case there are any questions, and then I think we can wrap up for today.
Oh,
I see a question about the data set. Do you want to
okay.
answer that, Joel?
Yes. Okay. The data set will be released when the challenge start, right? So right now you can join the challenge, but then the data is still hidden, and that is on purpose, right? You don't want. I mean, the hackathon is going to be the hackathon will start on Saturday the 28th. So the idea is we want everybody to have access to the data at the same time. I think that's fair, right? Nobody should have access
Hmm.
to the data prior and start working. So everybody has a fair starting point. Okay. So data set will be released on the 28th when the hack start.
10 a.m. EAT, 10 a.m. Eastern.
Right. But
Do
of
we have
course,
any other questions?
you can already start thinking about the challenge, brainstorming. I mean, you can start thinking about what you will do. Obviously, looking at the practice challenge and
Mhm. Good. Do we have any other questions before we wrap up this webinar? Seems like no further questions from the group. If you do have any other questions, you can always ask them on the Zindi chat page of the challenge itself, and we'll make sure somebody answers the question. We'll make the recording and the slides available as well. And yep, I think all that's left is to wish everybody good luck for the remainder of the program and for the challenge this weekend. Uh, Bye for now.
okay. Bye bye.
Bye bye.